These are our pre-calculus notes for 6-3. So 6-3, we're actually learning how to use that determinant and what it's for. We are solving linear systems using inverses and Cramer's rule, and everything is going to involve the determinant today. So just like a little recap about how we get the determinant. So determinant of a 2x2 matrix is we multiply on this diagonal, which is AD, minus our other diagonal, which is BC. So that's our determinant. If we do not get 0 for our determinant, that means that we can have an inverse. And the way we get our inverse is by doing 1 over the determinant, and then we multiply by this original matrix, but we kind of switch it up. So we switch our A and our D, and we change the sign on B and C. And that gives us our inverse matrix. So lots of stuff here. We're going to just practice this and break it down step by step. So in number 1, our first step is going to be finding the inverse using the determinant. So first step is to find the determinant. And we're pretty good at that from yesterday. So we're going to multiply, subtract, multiply. So -3 times -4 minus 2 times 5. So this part's review. So 12 minus 10 gives us 2. And now to find our inverse, we're going to take this determinant and use the reciprocal. So that means I now have 1/2, and we're going to multiply it by almost our original matrix. So we're swapping on that first diagonal, we're going to swap, and we're going to change our signs. So now I just have to go through, and I have scalar multiplication. I'm going to bring that 1/2 and multiply all 4 numbers by that. So this will be a -2, -5/2, -1, -3/2. So that's going to be my inverse. All right, so here's step 1. So the reason we might want our inverse then is to be able to solve. So if we look at what we have here from your textbook about invertible square matrices, what they're showing you is if I have A times X and it equals whatever my answers are, if I want to find that X, I could just go ahead and multiply my inverse by those answers. And by answers, I mean like this column right here. So let's just go through and kind of look at how this system of equations correlates to this first. So if I am going to write my system with my coefficients, I'd have -3, 5, 2, -4, and I don't know my xy. So I'm going to write my xy right here. That would be like the x I'm solving for. So here's my a, here's my x, and it's going to be equal to the 33 and the -26. And that's b. So this is kind of what we're looking at right now. And they're telling me if I want x, I have to take and multiply the inverse times that b matrix. So x equals a inverse times b. So that means we are going to multiply. I don't know if you noticed or not, but this is basically the same problem as problem 1. So we're going to multiply our inverse matrix from example 1 by b to find our x and y. So those are the steps that we're going to take. So let's just scroll up here really fast. I say scroll, but I'm just sliding my paper. And you might have noticed, if I back out a little bit, that our matrix up here for A and then which we just wrote out for our coefficients on X and Y are actually the same. So I kind of had you already do that inverse in part 1. We just were splitting it up. So basically at this point, then what I have to do is I have to take my inverse matrix that I found in problem 1, and I'm multiplying that. I don't like the way this turned out. Let's fix that. I'm just multiplying this by this matrix, this column matrix over here that had my, after my equal signs, what my quote unquote answers were. So this is going to give me my x and y after I multiply. So remember, we're doing a row times a column. So that means we have -2 times 33 plus -5/2 times -26. And I'm going to give you whole number answers or integer answers on these. So you don't really have to worry about fractions. I know it looks like there's a fraction, but they're all going to take care of themselves. And then I would have to move down because I'm doing a second row now times that same column. So then we'll have a -1 times 33 plus negative 3 halves times negative 26. And then I just want to go through and simplify these fractions. And let's see, this will be a negative 66 plus 65. And then I have a negative 33. And what is this one? Plus 39. So 1 and, negative 1 and a positive 6. So that is going to be my answer on this one. So we're going to go ahead and look at the back now. So on the back, we're using a different method to solve now. We're using Cramer's rule. So the Cramer's rule also involves a determinant. And I have a really hard time with the way they write this out. What they're trying to do is talk about X and then Y and then Z. And they use A1s and A2s. And I like kind of what they're trying to show here, but I think it's really confusing. So I'm going to say that X is going to be dx over d. Y is going to be dy over d. Z is going to be dz over d, and so on and so forth. And I'm going to show you how to get that. So we start out with just a 2 by 2 matrix, which is nice. And we're going to have to do determinants of 3 different things. We're going to have a determinant just of our normal matrix, and we're going to do this X determinant and this Y determinant. And I'm going to show you how we get those. So the first one, I'm just going to do the determinant of 4, negative 5, negative 3, 2. So it's a square matrix, they're super easy. We'll do the 4 times 2 minus the negative 3 times negative 5. And I always write down the minus and the negatives. I find I make a lot less mistakes when I just write everything out and then I fix it afterward. So this is going to be an 8 minus 15, which is negative 7. Okay, now when I find my X determinant, what I do is I take my answer column, the negative 49 and 28, I take those answers, and I'm going to replace my first column here, my X's, I'm going to replace that. So because I'm finding my X determinant, I get rid of the X's and I use my answers, the negative 49 and the 28. And you'll notice I'm not writing this exactly as a matrix. I'm just putting these lines around it, which was our notation for finding the determinant. So I could put the notation on this side or I could put it on this side. The textbook I'm using just puts it around like the matrix part instead. So I don't think it's a really hard and fast thing. It's like a textbook preference for how we write our answers. All right, so this way I'm going to negative 49 times 2 and then minus, and then our other diagonal is 28 times negative 5. So let's see, this is going to equal what? Negative 98 plus, let's see, 20, 40. So 140, which is a 42. And remember, we're going to make fractions out of these. So the fact that I can do 42 divided by negative 7 evenly is a really good sign, because you know I'm not going to be giving you weird fraction answers on these. So they should be nice answers. So to figure out my Y determinant, I keep the X column, the negative 4 and 3, but now I put my 49 and my 28 in for the Y's. And this probably seems like the longest way to solve a system of 2 equations ever. But I think before we do a 3 by 3, it makes sense to do a 2 by 2. So to get my Y determinant, I'm going to have 4 times 28 minus the negative 3 times the negative 49. So let's see, 4 times 28 is 112 minus 147, which is a negative 35. I can also divide that by negative 7, which is a really good sign here. So the way I get X is by doing dx over d. So my X determinant over just my original determinant. So let's see, that's going to be 42 over negative 7, which is going to equal negative 6. And then my Y value is by doing dy over d. So my Y determinant was negative 35. That was a value. And my original determinant was just a negative 7. And so Y is going to be 5. So my answer is negative 6, 5, which again, it's pretty cool the way it works out, but it is like a completely inefficient way to solve a system of 2 equations. But we wanted to practice here before we move on, and we have 3 variables now. So the three variables working with our system, our 3x3 matrix, is going to work a lot the same. Only we're going to want to write smaller because we only have half a piece of paper. And now we've got our original determinant, the y, the x, and the z. We've got three of them that we need to worry about. So first I'm going to do my original determinant. So this first equation or row has 0 for x, and then I have a 1 for -1. My second row or equation is 2, -2, 1, -18. I know one thing I'm struggling with for mistakes is that when I see z's, I keep thinking 2's. So if you're making that same mistake like me, watch out really carefully for that. Oh, you know what? I did not even mean to write this down, did I? I don't want that there. I'm only looking at my coefficients. So when I find the determinant of a 3x3, what I have to do is take those first two columns and rewrite them. And then we're multiplying on our diagonals again. So I'm going to have to multiply these three. 0 times -2 times -4 plus these diagonals that we draw first are the positive ones. The negative ones are going to go in the opposite direction. Plus 4 times 2 times 0, and then minus. So now we're going to work the other way. 1 times -2 times 4 minus 0 times 1 times 0. We love the zeros. Minus -4 times 2 times 1. So let's just go through and work this out. 0 plus 1 plus 0. This is going to be a +8, another 0, minus negative, another +8. So it looks like D is going to be 17. So that means all these other values that we come up with should be multiples of 17 because I'm not going to give you any fractions on this. So to find my x determinant, just like before, I replace my x column with my answers. So I'm going to start with -1, -18, 7, and then my y's and my z's are going to stay the same. When we do our y determinant, we'll replace the y's. When we do our z determinant, we'll replace the z's. So it should remind you a lot of the easier 2x2 matrix that we already did. And I'm just rewriting my first two columns. And then we'll do our diagonals. And it doesn't matter how many times I do this. As I'm doing it, I'm always drawing my diagonals. It's just all those little things that help us to make less mistakes. So there's my first diagonal plus 1 times 1 times 7 plus 4 times -18 times 0. And I'm not trying to think ahead and work anything out and think, oh, that's a 0. I am just writing them down right now. So I found that just helps us make less mistakes. So now all my other diagonals I'm subtracting, they go the opposite way. So minus 7 times -2 times 4 minus 0 times 1 times -1 minus, I'm running out of space here, -4 times -18 times 1. So now I've got to go through and do all my simplifying. This is going to be a -8 plus a 7 plus a 0. This one's going to go to 0. Let's see. Plus 4 times 2 times 8. This is going to be positive, so 8 times 7 is a 56. And then minus a 0. And then the last one is going to be, let's see, a minus 72. And that's kind of off my page here. I have a minus, minus, minus. So minus 4 times 18 is 72. So to finish this off, this is where you grab a calculator. And this should equal -87. Let me go through and double check. -17. So already I can tell that -17 over 17, that's going to be an answer for x. So I'm good there. So now I'm going to do my y determinant. So for my y determinant, I keep my first column of x's the way it is. But my middle column, for where my y's go, that's where I'm going to be replacing. So that's now going to be the -1, -18, 7. So I'm kind of going back to, let me adjust this a little bit for us. So I'm going back up to the top, and my first column is going to be this. My second column is now the one I'm replacing. My third one's going to stay the same. So let's just finish writing this. And despite my best efforts, I'm just going to need another piece of paper. And that's all right. We'll just use another piece of paper. So when I go to multiply again, I want to do my positive diagonals. Oh, I got to rewrite, don't I? Plus, let's see, -1 times 1 times 7 plus 4 times 2 times 7. Now we're going to do our minus diagonals. So 1 times -18 times 4 minus 7 times 1 times 0 minus, our last one is -4 times 2 times -1. All right, and then we're going to go through and simplify again. So this is going to be a 0 and a -7. Let's see. And what comes next? -1, 1, 7. I'm just making sure I have the same answers I did before. And I am missing something. This should be a 1 right here. That's what I'm missing. All right, so that's a 1. It should have been a 1 here. No, it should have been a 7 on that one. Okay, so now that I've got that fixed, let's just make sure. It's a good thing I did this problem earlier. -1 plus 56 plus 72. And then this is going to be a 0. And at the end we have, let's see, a -8. So we'll just go through and work that out. That should be 119, which is actually a multiple of 17 again. Thank goodness, right? So now I'm going to have to do my x determinant. So x determinant is going to work the same way. I'm going to keep my original 2 columns. And all I'm going to do is change that last column. The last column is now going to have my z's. So we're finding dz. So the 0 to 1, my original x's stay the same. My original y's, it looks like those were 1, -2, 0. So this is back to my original determinant. I'm keeping the x's, I'm keeping the y's. And now where the z's go, that's what I'm replacing this time. All right, and then we're going to rewrite our first 2 columns. And we'll do our diagonals again. So multiply these 3, plus multiply the next 3, plus the last one, which has a 0 in it nicely. Okay, now we do our minus diagonals. So we'll multiply here. Minus 0 times -18 times 0, minus, and our last one is going to be 7 times 2 times 1. I had to write really small to fit that one in. So we'll go through and we'll simplify again. So let's see, this first is going to be 0. And then we have a -18, or sorry, -14. And then, oh no, we do. We have a -18. I was looking at the 2 and the 7 there. So we do have a -18. And this is another 0. Negative, negative, negative. So this will be a -2. And another 0. And 7 times 2 times 1 would be a -14. So -18, -2, -14. Let's see, this is 20, 34, which again is a multiple of 17. That's a really good sign. So when we find our x, it's by using dx over d. Our y is going to be dy over d, and our z is dz over d. So let's go through and just plug in our numbers. So my x determinant, I had a -17. My original determinant was just a 17. So my x is going to be -1. My y determinant, I had a 119 divided by 17 is, turns out, just 7. So that works out nicely. And my z determinant divided by d would be -34 over 17, which is -2. So what I really like about these problems is because we know that you're not going to get any fraction answers, I'm just not going to give you those. You have some confidence as we're working it through. And then if you want to check your answer, it's just a system of equations. Go back and check your answer. So because this whole unit has a lot to do with systems of equations, you don't have to solve and then wonder if you're right or not. There's ways to go back and check it out and to do that. So if I were you on a test or quiz, I would complete the whole thing, and then I would go through and do some answer checks. And if there's something that's wrong, instead of erasing everything and starting over and possibly running out of time, that's when you want to grab that new sheet of paper, right? And start solving on a new sheet of paper. You can always attach or cross some stuff out, but as long as there's something written down, you're going to get some partial credit. If you erase everything and start over, you might completely run out of time. So that's just some random test taking strategy stuff thrown in here as well. So hopefully this was a pretty easy lesson today. I really like that about 6-3. And if you have questions, make sure you let your teacher know.